Hi guys, this is the fourth time that I've tried to make this video because my phone kept deleting them. So I tried to clear up some space, hopefully we're there, but to say I'm frustrated would be an understatement. So, here's the key about this entire lesson. If I say 0 divided by 20, is that equivalent to 20 divided by 0? I would love you to get your calculator and do both of those problems. So take your calculator, do 0 divided by 20, and my guess is you will get 0. My guess is when you do 20 divided by 0, your calculator will give you an error. You do not know enough math yet, and mathematicians still try to work it out, but it's undefined when we divide by 0. We are not allowed in mathematics, especially up to this point, to have a 0 in the denominator. So that's going to come in huge when we've got variables in the denominator. Because again, today's lesson, if you take one thing away from today's lesson, it's that the denominator cannot have a 0. So rewrite 10 divided by x plus 5 as a compound statement. So first, the expression stays, whether it's the expression, whether it's the equation, 10 divided by x plus 5, and we need to know about that denominator. So to figure out what the denominator cannot be, we know that denominators cannot be 0. So I take the denominator and I make it an equation. I set it up equal to 0. When we subtract, we get x equals negative 5. Well, what's that telling me? That's telling me that when x is negative 5, the denominator is 0. Are we allowed to have a denominator of 0? No. So we're going to write this problem as a compound statement of this expression and x cannot be negative 5. This expression will work, but x cannot be negative 5 because denominators cannot be 0 because it causes us to have an error. So what does that mean long term? Well, let's do another expression. Is it permissible that x equals 5? So the first thing that we need to do is check to see, can 5 make the denominator 0? 5 squared is 25 minus 9, that's fine. 5 plus 4 is 9, that's fine. Okay, so it doesn't make the denominator 0. 5 squared is 25 minus 25. We've already said that if the numerator, and we get any number, let's call it 12, it doesn't matter. Any number in the numerator that's 0 is fine. So is 5 allowed? Yeah, 5's allowed. Is it permissible to let x equals 3 in this expression? Well, we don't know. So we're going to take this portion and this portion and solve them for 0. Add 9, that leaves me x squared equals 9. When we are solving an equation that's a squared, we take the square root. And remember, it leaves us two answers, a positive and a negative 3. Because negative 3 times 3, or let me try again, negative 3 times negative 3 is 9, 3 times 3 is 9. So I have two answers that it can't be, and then I subtract 4 because that equals 0, and x equals negative 4. So all three of these, positive 3, negative 3, and negative 4, would put the denominator at 0. So can x equals 3? Well, watch. Let's substitute it in. 3 squared is 9. 9 minus 9 is 0. 0 times anything is 0. The denominator is 0. So no, it's not permissible. Give all the values that are not permissible. Well, here we are. X cannot be negative 4, negative 3, or 3. Those are the three things that x absolutely cannot be for the denominator to be 0. So what happens when it's an equation? Well, we're going to do two examples and only two examples. One is easy, one requires a little bit more work. Rewrite the equation into a system of equations. Okay, so when we rewrite it into a system, again, we're doing two things. We're making it into a compound type of deal here. So we're going to say, okay, what do we know about this? Well, we know, am I even in the right lesson here? What lesson we're on? We're on lesson 18. Oh my goodness, where am I? Rewrite, 1 divided by x. Where is it? Oh my goodness. Oh, there we go. Shoot! No wonder I was confused. Okay, so we're going to rewrite it as the equation 1 divided by x equals 3 divided by x minus 2. And x cannot. Well, what can x equal? So we take these two. We set them up equal to 0. X equals 0. X minus 2 equals 0. Well, we've already got one. X cannot equal 0. There's another one. When we add 2, x equals 2, and x cannot equal 2. This is the compound statement. So now when we solve the equation, and here's the key, if there's just x's in the denominator and not in the numerator, we just cross multiply. So this becomes 3x equals, this becomes x minus 2. So I'm going to subtract x from both sides, leaves me 2x equals negative 2. I divide by 2, x equals negative 1. Well, is that my answer? No, because you need to have your answer of what it can equal and what it cannot equal. So x equals negative 1, and x cannot equal 0, and x cannot equal negative 2. You have to show what it can be and what it can't be. And I just had steak for lunch, and it's not sitting well. Like, almost to the point where I'm getting a little sick to my stomach, and I'm not quite sure what's going to happen. So if I vomit on camera, surprise. Okay, so now, this one's different. Notice it has x's in the numerator. So we do something different for this. So rewrite the system. X plus 3 divided by x minus 2 equals 5 divided by x minus 2. Okay, and x cannot equal. Well, they're the same. So x minus 2 equals 0, add 2, x equals 2. So x cannot equal 2. Solve the equation. If there's an x in the numerator, we're only worried about the numerator. Now, are there other ways to solve this? Yes, but that's how Engage New York wants us to solve this. This is not how I would teach the math, but I'm going to go with Engage New York. This is how it wants us to solve it. If there's x's in the numerator, just deal with the numerator. We'll talk more later in this year about this. Subtract 3 from both sides. X equals 2. Well, solve it. So x equals 2, and, wait a minute, x can equal 2. So how is this possible? If x equals 2 and x can't equal 2, well then, there's no solution. It's a null set. Because the solution that we get is not allowed to be a solution, because when we substitute in that solution, the denominator is 0, which causes an error. So we're going to do more of these in class. The key concept for this whole lesson of lesson 18, is to make sure that the denominator cannot and will not be 0. If the denominator is 0, we're done. It's not good. Next lesson. Let's go.